Hi, welcome to a new video. In today's lecture, we're going to talk about exploratory data analysis, EDA. By far, this is one of the most popular statistical analysis that exists because easily 90% of the times that you are going to perform some data science analysis, you need an EDA as part of it. It's typically it's like the first step in every single data science pipeline. You need to perform an EDA in order to understand your data. Now, the EDA typically it has some guidelines. There are some like key elements, like visualization is important, some statistics. However, there is no like a framework or a methodology that will guide you, like through the whole steps of the EDA. So that's why I'm proposing the Quest framework. So you won't find it online if you are, like trying to look for it. But I will define it because again, it's based, of course, on those guiding principles. So in the methodology that we will cover in this video, so each word stands for like a step in the process. So we have Q for the questions that you need to answer before the EDA, understand your data, explore individual variables, study their relationships, and then tell a story about your data. Okay, so what is EDA? Let's say that John Toki was he was the first person that defined EDA, and he said that EDA is detective work. So you need to have like an open mind. You need to be ready to be surprised by your data. So it cannot be just like finding what you're expecting to find. You need to be open to different alternatives. So EDA is hypothesis generation, not confirmation. So here you will have questions and you will identify some hypotheses that you will need to test later. So EDA is not a linear process. Actually, it's a iterative process. That means that once you move to the next step, you can go back. And that's very common because sometimes, let's say that you have analyzed, missing data, and now you are comparing and you're performing some like correlation analysis, and you find some like weird variables that are connected. So sometimes you need to go back because maybe there was an error at some point in your pipeline. So you need to fix some variables, right? So that's why it's an iterative process. So you have to be open to go back to previous steps at any point of your EDA, even at the end. Even once you have arrived to some conclusions, some insights, you need to go back to your initial questions to make sure that like you're answering all of those, or maybe there are new questions. So that's why it's an iterative process. It's a disposition towards surprise and discovery, right? Detective work. And as I mentioned at the beginning of the video, is the foundation of every single analytical pipeline. So you need an EDA always. So what is not EDA? So it's not a one-time preprocessing step. I want to mention this because nowadays, since we have like all large language models available, ChatGPT, Gemini, Cloud, and similar. So with a single prompt, like we get a lot of plots, a lot of statistics, like very just with a single plot, with a single prompt. So that's not, I mean, yeah, that's part of the EDA, but we are missing a lot of things if you just get like that those plots without context. You need questions, you need business problems that you want to answer actually before moving forward to create those plots. So it's not just about populating slides with plots. It's about really getting some insights and answering key questions. So it's not about creating a lot of charts. Like you need an intent for that. So you just be careful. Okay, just to give you a little bit more of like historic perspective of EDA. So John Tukey, he was the one who defined the process of EDA. Then Cleveland gave some foundations about visualization and the importance of plots in this process. Especially John Tukey, he proposed like the importance of descriptive statistics, like key metrics such as the mean, standard deviation, percentiles, and also Tukey was the one who introduced the box plot, which is really important nowadays. Later on, some authors pointed out the importance of asking questions and also developed some modern libraries that we use nowadays, ggplot2, for example. Those ideas are the software was really important for data visualization at a specific moment in time. And nowadays, what we have is like we're using LLMs for the EDA, which I mean is good because you can get an EDA fast, right? We can automate a lot of steps in our EDA, but again, you gotta be cautious about. You need to be involved in the process, not just prompting. You also need to be involved in terms of guiding AI, in the process, and especially the insights. All the conclusions at the end. You need to check. You need to validate that they make sense because you are the one who knows the context, right? So let's go over the quest framework that I'm proposing here for the EDA. So the first stage is ask questions, define the mission. The second one is understand the data. So we need to audit and check the quality of our data. We need to make decisions about our missing values. Then we explore the individual variables, histograms, density plots, for example. The study component is when we start combining multiple variables into our analysis. So we have some basic stuff here in the study. So typically you will find, correlation metrics, some box plots, scatter plots for sure. If you prompt it, an LLM will give you, the basics. But I will advocate to also include like machine learning models here. So it would be nice if it's possible. I mean, if it makes sense, you don't have to push it. You will use them only if they make sense. So clustering analysis here is nice when you want to group data, see if there are some patterns. Dimensionality reduction. It's important and we will cover that topic in this class in around 3-4 weeks. Dimensionality reduction helps to visualize data when, let's say that you have like 100 variables, 50 variables. Of course, they won't fit in a single plot. So using dimensionality reduction techniques, it's possible to represent, a big number of variables into a single plot. Of course, you lose some information, but you get at least an idea of the behavior of your dataset. And at the end, we have the tell, which is to communicate the insights. It's important to iterate and ensure that when you summarize, when you finish, you're actually answering all these questions, right? Okay, so let's go over each of the steps in more detail. So the first one, the questions. So you need 3 up to 5, very specific questions that we can confirm with the data that you have. You also need to understand who is the audience of the EDA output, who's going to use, that information. It's really important if there are which constraints you have during your analysis. So this is the first step. And actually, the advice here is do not create plots, do not create charts until you have defined your questions. It's not about, okay, I create the plots and then I try to make sense of the plots. That's not the way it works. You need to plan. You need to plan. So the first step in order to plan what the plots, the chart that you need in your EDA is to have a list of questions that you want to answer. So no plots at this phase. This is just conceptual planning. Now, in our second step, understand. So here we need to check the quality of the data. So that means that whether we have duplicates, if we have, some coding issues in some of the categorical variables, that's common. Sometimes, for example, gender, we have F or female, like same category, but using different codes. So you need to check that, the integrity of your data. That's possible. Another thing that you need to check here, it's missing data. Um, Typically, people will think, okay, if I have missing data, I can maybe remove some of the data, or we can use some imputation techniques, and that's fine. But you need to check why that data is missing. So there are like some like missing values. They are not always like randomly missing. There are some, let's say, there are some relations with other variables. So let me explain to you a little bit more clear. So here we have the three possibilities. In the first one, missing completely at random, MCAR, means that if there is a variable without some values, if you have that scenario, that means that it's completely random. For example, think about, imagine that you have a sensor and you collect data with that sensor. But at some point, the sensor is failing. So sometimes that sensor is not reporting the value, it's not measuring that variable, right? But it's doing that problem randomly. So there is not like a pattern. It's not related to other variables in your data set. So that's missing completely at random. Then we have missing at random. So this is when the missing value it's correlated to the other variable that you can see. So let me be a little bit more specific. Let's say that in your data set you have like three variables, x1, x2, and x3. So let's say that this analysis is about, like we have different companies. We have some financial metrics. We have information about whether the company is big, small, number of employees, the industry, and things like that. So let's say that x1 is a metric about like, let's say this is the percentage of orders delivered on time. So maybe for some reasons, big companies, for them it's easy to track. They have like good software that will be able to collect this data easily. So they have this information, no problem. They have this value. So let's say that for the first company that's 100%. So they have that information, right? And then they have other information here, like size of the company. But there is another company here, another observation. For them, let's say that they are a small company. So the value here, they don't have it. The software that they have, it's not tracking that specific variable of orders delivered on time. And now, there are some variables in the dataset that are seen. For example, you have like the size of the company, the industry, but the problem here is like the missing value is not because this variable. I mean, the variable, this variable is not the problem. We have this missing value is because the other variables. It's because this is a small company. I mean, the other variables can explain why we're missing this value, right? So when this happens, you can do some sort of imputation. You can use these variables to predict the missing one, right? So this is what we call missing at random. And then we have the third possibility here is missingness not at random. So this is when the missing value is because that variable. So let me give you an example. Let's say that we are, following some patients, and we're performing some like psychological test in our patients. And one patient doesn't have like a score that is testing, his mental health. And the reason that is we don't have that value is because it's so high. Let's say that the patient has a problem, like a mental health problem, and that's affecting that he's not attending he's not going to take the test. He's not going to the controls. Therefore, the reason why that variable is missing is because the value of that variable, because it's too high, that the patient is not going, because it's been affected, right, by that value. So a similar example is for some companies that, let's say that they do some trading, like they manage portfolios. So sometimes when they don't do that well, they don't show the return per year, and they don't show that information. So the reason they're not showing is because of the value. It's small, right? So that's missing not at random. Is when the value that is missing is because the value, right? It's too high or too small, but it's related directly to that specific variable. So we have these three differences. Now, why this is relevant? Because if you know this, then you can make decisions about, okay, what I'm going to do about this missing data. So this is important. You cannot assume that in every single scenario is just completely at random. No, it depends. You need to check that. All right, so in the understand stage, the whole idea is to check that your data, you can move forward in your analysis. That is correct, that there are no mistakes, but it is possible that maybe we don't catch, like some errors here. And later, during the exploratory or the study steps, we, like they kind of like they show up. So we need to go back to this stage. That's why we mentioned this is an iterative process. The explore. So this is for individual variables. So here, when you have numerical variables, categorical variables, what we will do is like use histograms, density plots. We want to evaluate the shape of the distribution of our data, if it's skewed to the right, to the left. We will identify if there are outliers. Now, this is important to mention here. Typically, when people mention EDA, people imagine that this is for numerical data and categorical data, but you can perform an EDA to any type of data. That can be text, images, video, sound, like different data types. Actually, nowadays, our LLMs are getting what we call a multimodal. It means that they combine, different data types. So we need to also prepare our EDAs to be able to handle multimodal data. Because if the tool that you see here, these are the typical tools that we use in EDA, but these are mainly for numerical and categorical variables. But keep in mind that here we can also analyze other type of variables, and we will require different tools. In this course, we will go over them. We will learn how to perform an EDA to text, not right now, but later in our course. The S is for the study. So, as I mentioned before here, the typical analysis will include some correlation matrix, Pearson. This is for linear correlation. Also, you will see some heat maps. That's very, very common. Correlation heat maps. Scatter plots. They are very common when you want to see, especially for regression analysis, you want to see if X is related to Y. I really think that a good data analyst will include models here. That will be my advice. If you wanna stand out and like someone that it's different than the rest, I think you should improve your game in the EDAs using models. That means using clustering analysis, adding some trees, regression trees, classification trees to explain the data. Because with these models, you can identify patterns that you won't see with your eyes. It's difficult. Sometimes just by looking at the plots, we can miss some things, but using some algorithms, some specific models, we can identify better some patterns. So this will enrich your analysis for sure. So please keep an eye on this. I will show you some examples before I just show you the last step, and then I will go over quickly through one of the examples. So the tail is the last stage of our framework. And here, the idea is just to make sure that we are answering all the questions. Here's where we collect our final insights and we communicate them. You can create a dashboard if you want here. And of course, we need to iterate always. That's critical and it's really important throughout the whole process. Because remember, this is not a one-time analysis. Okay, So let me show you how it looks. So I will go real quick. This is an example. So we will cover the steps. The data set is about hospital readmissions. So again, some context. The key idea here is that we want to analyze which variables were important or were somehow correlated to patients being readmitted within 30 days after being discharged from the hospital, because that affects like there are some issues with the insurance company will like have problems will have problems with the hospitals, because if a patient is released and then is readmitted, it means that maybe they release the patient too early, so that that there are some costs involved in that early. Okay, so the first step it's you. So let's. I'm sorry. The questions. The questions here are: so what patient and hospital characteristics are correlated or associated with the 30-day readmission? That makes sense. If there are some errors in our data, problems, missingness, we're going to analyze that, and we want to check the association between readmission and the other variables. So to understand, we check. Remember, here is where we check the like for missing values, data that is coded, in a weird way. For example, here see the example female. We have F, and then the word female. Same thing with male. So that's an issue in our data here. So we analyze we count, and we measure the percentage of missing values. So here you see we need to change the code here. We need to group some of these categories. Same here. We have some repeated categories here. We have white and it's mixed with this one. So that affects your analysis, right? If you keep moving forward, you need to ensure that you consolidate those category values. The missingness, this is in the same step. So here the critical variable is creatinine. So it's 12.2%. That means that let's say if there are 1,000 observations, when we're missing 120. That's pretty much the 122. Okay, so this place to visualize the missing values. This is important because look, in the y-axis in the x-axis we have creatinine present in the data or creatinine missing in the data, and we're comparing with another variable, which is a comorbidity index, and you see that there are differences. That means that this variable is somehow correlated with the missing values, right? So it's not random. The missing values are not random. There is something happening, right? There is an issue with this variable that affects this one. So an hypothesis here is that since the patient has, like other disease or like multiple issues, diabetes, like things like that. So maybe that's affecting the when they're gonna run some, like when they're gonna draw some blood for the blood tests for the work. Maybe these patients are more sensitive, or they are not stable enough, for that procedure, and that's why they are missing these values. So again, that means that the missingness here is not random. It's given, other variables in your data. So that affects the way in which you are gonna handle those missing values. All right, then we have the E, where we explore each individual variable. So we see the shape of them. I'm going a little bit faster. For numerical variables, for categorical variables, we see if they are balanced or not. So here they are not balanced. We have like 82% and almost 18%, right? So these classes are not balanced. This is relevant, especially when you're creating a model later. Not as part of the EDA, but let's say that you want to create a classification model to predict whether a patient is going to be readmitted or not. So if data is not balanced, that might affect the model performance. The study is when we combine multiple variables to see, the relationships. So you have typically you will see correlation variable, correlation matrix like this one. Then also we start mixing our, other variables. We'll use box plots here, scatter plots, depending the situation. So as I mentioned before, I really recommend using trees. So this is, since in this problem, the key variable is whether the patient is readmitted or not. It's a classification problem because it's categorical. It's a categorical variable. Therefore, this is a classification tree. So the nice thing about the trees, I won't explain a tree in this video because it's not the purpose, but just let me give you an idea of why they are important. Is because it shows which variables are relevant to make that classification, and not just which variables are important. It also shows like the cutoffs, like for which values of that variable they are important to make predictions about the if whether the patient is going to be readmitted or not. So you can perform some feature importance for that here. It's like if the patient has some prior admissions in the last 12 months. Remember the comorbidity index we saw. So these are important variables that affect the readmission. And the last part, of course, is the insights that you get from the whole analysis, and you need to communicate them, and you need to ensure that they really answer the initial questions. That's the important thing. In the same file, you will find two more examples. Like when we apply the quest framework. Okay, so best practices. Start with the questions before touching data, because that's unfortunately most of the people don't do that. Right? It's like everyone start just like plotting, creating multiple plots, and then try to make sense about those plots. No, you need to plan before coding. It's important to use both. Descriptive statistics, they are important numbers, but visualizations are critical. Let me show you why. Because I really like this example. Let me show you. This is a dataset called Datasaurus. I'm gonna upload it into our Brightspace, the Datasaurus. So it's a basic dataset. There are different inside that dataset. There are multiple datasets actually. We have also the X value and the Y value for each observation. So the first thing that I'm going to do is just to create some descriptive statistics per dataset. So I'm just going to group my observations per dataset or by dataset, and then I'm going to describe X and Y. So the datasets, there are multiple. We have away, both sides. These are the values of that variable dataset, right? And if you check the mean value and the standard deviation, they are like pretty much the same thing, right? All of them, they look similar. So if you just look at the numbers, you can think, oh no, these observations or these datasets, they are the same thing, right? Because the same mean value and the same standard deviation. That's because we're just looking at one specific part, of the picture. But if instead of just looking at that, let's say that we visualize our datasets, now you see that they are completely different. Even though they have the same mean and the same standard deviation, look at the shape. It's completely different. This is the dino. It's different. We have stars. We have, you will miss information if you don't visualize your data. That's the key idea. So that's why you have this best practice. So use both visualization and statistical summaries. Iterate through the pipeline. I mentioned that several times in the video. So this is not a linear process. You can always go back. It's normal. It's normal. I mean, when you're doing EDAs, you will, especially with real data, you will struggle. Like you will get errors sometimes. You will get some weird patterns. So you need to go back to ensure that the quality of the data is correct. Do not forget to document every decision, every assumption in your data pipeline, because at the end we want that this EDA, we want it to be reproducible, that we can repeat the same steps, because most of the times or companies you will do an EDA for the same data later. That happens all the time. So you need to ensure that you can reproduce the steps in the same way. Okay, some final advice uh, for EDAs. Given like the technologies that we have access nowadays and they are improving so fast, I'm talking about AI, LLMs, agents. So what we're doing, and it's gonna keep growing. We're gonna automate EDAs, like, and more processes. So they are very common, like it's very common to have some initial profiling reports in Python. There are some libraries that with a single line, you get a complete EDA. It will give you, like all the correlation matrices, all the plots. The problem is that they don't have context. So it will only plot everything, which is fine because it helps, right? But you need to provide the context. So you will automate the initial profiling for the missing values, for the validation. So that's easy to automate. Now, in order to explore your data, now people are using LLMs, right? So for code generation, to visualize different plots, to debug your code, to suggest different models, right? So LLMs, they are welcome in these steps. Now, what elements of the EDA you should keep manual? Even, like as technology advances, here you need more intervention. The first step in the questions, defining questions and objectives. So you shouldn't hand over that part to LLMs unless they are like, like very trained in your process, which at the moment is not like that. At the moment, I'm talking about 2026, February, but you never know. This is going too fast. But right now, it's not smart, like giving to the LLM this power. You need to provide a guideline, what you want to check in your EDA. You are the one who asks the questions based on the context. So when there are some anomalies in the data, outliers, some missing patterns in your data, and they are domain specific, you shouldn't give that away to your LLM because you need to take care and control of that situation. At the end, when you are doing, getting the insights, the narrative that you're going to present, also that belongs to you. So human intervention here is critical. It's critical in these steps. So these are just recommendations. But again, this is going so fast, and people rely too much in these tools, which is fine to some extent, and it's fine for some specific elements of the EDA and the data science process. But again, there are some elements that are way too important, and you should keep that control. Okay, guys, this is everything for now in this video. So remember, EDAs are key for your success as a data scientist, because I don't know if you're gonna do a predictive model in the future. I don't know if you're gonna do some causal analysis in the future, but I know for sure that you're gonna do a lot of EDAs if you're working with data. Okay, so I'll see you next video. Bye bye.